Hello everyone, welcome to lecture 4 of the Python series for BSc IT Python programming. So today's lecture is based on functions. So let's get started. First slide we will see what function calls are and what is a function. So by function we mean that it's just a name sequence of statements that performs a computation, and we do usually use Python functions which are generally built in quite casually in the program, but we don't realize what goes on in the backend. So type is one of the function which we generally use to know what is the type of the value. So in this case, the type of the value would be int. Next point here is the result of the function is called the return value. So what we get in return after calling the function is known as a return value. Um, how does the function look? Maybe I can give you an example. Yeah. So this is an example of a very basic function where the name of the function is calculate power. The parameters it receives are base and exponents, which are then specified in the round brackets. The first line here you see is the function header. Next few lines are the function body, and here we have a return which marks the end of the function. So as we specified earlier, that function is just a collection of statements. I'll just copy this on the first slide. Should be easy to refer then. Yeah, a function is a name sequence of statements that performs a computation. So this is just name sequences which performs a computation and then returns a result. So in this case, what this function does is it takes the base and the exponent, and starting from um, base up till 1, it will calculate all the powers. So, and the list would be all of these results which would be returned to us. Moving further, next we have type conversion functions. So these are built-in functions which help you to convert value from one type to another. So for example, I can say we have int, float, str, bool, and bin. So bin is usually used for converting into binary. We pass a string and it will be converted into binary number. Further, we have some working examples. So in 32, we'll convert the string. So we can see that this is a string which contains 32 into number 32. Then we have str 3.14. You want to convert this floating point number into a string, so use the str function. Just a quick note here, while using built-in functions, you have to be careful that usually what happens is we tend to some of the times we might be in a hurry and we might pass not a valid data type to the function. So in that case, mm, we will have an error then, and the error would be value error. So be careful with this thing while using any kind of function. Next, we have the math function. So these math functions are basically the built-in functions in Python, and these functions are available in the math library. So we import these functions by writing import math statement in the program. So first point here says that all the math functions are stored in the math module. So that is what I specified earlier. Then module can be imported with the statement import math. That is the second point on how to import how to import a math module in our program. Next is on printing the math module, we get the following output. So here I just wanted to show that after importing the math functions, can we print the functions directly? But no, we have to write math dot and then the function name in order to use the functions. So this print statement just specifies that what math contains is just a built-in module. One of the examples, next point is, one of the examples of the math functions are math.sqrt. So this is just a normal function and we are using it to get the required output. There are many other functions like abs, sine, cos, pow, which you can use to get the required computation. Next, moving on to the next slide, we have composition. This topic emphasizes on how, first point says, this topic emphasizes on how we compose our program using constructs like variable, expression, statements, and values. Yes, and second statement says that one such case is that argument to the function can be composed of quite complex expressions. So I think what we are trying to say here is that composition basically focuses on how do you make your program using basic constructs like expressions, statements, values, variables. So mostly focus would be on how legal the constructed or the composed statement is. So last point here says that composition focuses on how you can legally compose the program by following the syntactical rules. Like on the left side of equal to, you can only have a variable, etc. Variables, or in case you are having a tuple unpacking, you can have multiple variables. But yeah, this is a focus on how legally you construct the statement. Next, we have adding new functions. So first point here says that new and custom functions can be created using the def keyword. So for defining any function in Python, we have to begin it with def and then the name of the function. So yeah, this is a one line example of a function where you have a def keyword and then the name of the functions, the parameters it would accept, and then the return statement. Third point here we have is the rules for function names are the same as for variable names, like letters, numbers, and some punctuation marks are legal, but the first character can't be a number. Next point we have is the empty parenthesis after a function indicates no argument to that function. So what I mean by this is if we don't write any names within this bracket, then we will have no arguments to the function. Next we have is the first line of the function is called the header and the rest is called body. So this is called the header of the function and the rest of the statements are called the body. The function header must be terminated with a colon and the body should be indented by 4 spaces. So here we can see that in order to include these statements under the function calculate power, we have to provide 4 spaces. So yes, this is there. Moving on to next slide, we have definitions and uses. First point is that the point to be emphasized here is that the function should be defined before it is used. So what this slide basically says that in order for us to use a function, we first have to define it and only then we can use it. So here we have second point as if you make a function call before defining it, you will get a name error message in the program. So here I have a very small program where what I have done is I have written a function print world and I've tried to use it before defining it. So on running this program, I got the error on the right hand side, which you can see that I have highlighted. We got the name error message, and this would usually happen when you try to use it before defining it. So be careful when using any custom functions or any other built-in functions which you're trying to use without importing the library. Next, we have flow of execution. Execution always begins at the first statement of the program. So in Python, the execution or the interpretation of the Python program starts from the first line. So that's why when we were looking over this program and we called print world first, we were not able to find the definition because the definition was further ahead and we called it before defining it. So that shows that the flow of execution for Python is from top to bottom. Next we have next point we have is statements are executed one at a time in order from top to bottom. Third point says that a function call is like a detour in the flow of execution. It jumps to the function body, executes it, and then returns back. Yes, so basically what this point emphasizes is that function call is just a detour in the normal flow of execution. So how function calls usually happen is when executing current statements, it will stop the execution at the function call, go to the definition of the function call, execute all the statements, and then come back to resume the normal flow. So this is kind of like a um, break in the normal flow of execution whenever there is a function call. Maybe it will be a custom function or a built-in function. So here I have the same program which I had on the earlier slide. So you would get the name error. So that's what, sorry. So that's what this text block emphasizes here. Also, I have given a small note here that there is a module known as trace. Sorry, I want to highlight it. Yes, module known as trace, which can be useful for tracing the flow of the program. I have included the link here. You can access this when I share these slides on my GitHub profile. Moving forward, we have parameters and arguments. So when you call a function, the values passed to it is called as arguments. So what is the major difference? Let me go first over the second point and then I'll go in a little bit more detail. So inside the function, the values are assigned to variables called parameters. So what I'm trying to say here is that in this snapshot, we can see that this is a function called print twice, and whatever name we specify in the brackets here is called as parameters, and whatever name we pass when we're calling this function is known as argument. So that is the basic difference. So what does the text in this snapshot says? This function assigns the argument to a parameter named Bruce, which is this one. When the function is called, it prints the value of the parameter, whatever it is, twice. So we'll just print the value of the parameter twice. This function works with any value that can be printed. Okay, moving on to the next slide. Variables and parameters are local. So any variable which you declare inside the function or any parameter you're trying to access in the functions are all local to that function and cannot be accessed outside the function. So here we have def cat underscore twice part one part two. So here cat is a variable which is accessible only inside function. So when we try to access cat outside the function, we'll get a name error saying that name cat is not defined. The text here says that when trying to print cat, we encounter error because the scope of the cat variable is only limited to the function definition body. If you want to access the variable inside a function, then return the value back with a return statement. So if you want to access cat value outside the function, you have to return this variable cat. So we save this and move on to the next slide. Yes, so now we have the stack diagrams. So basically what happens is stack diagrams, this is just a theoretical concept. It helps us to visualize what variables are present at a given function definition or in a module when we are executing. So what we have as first point is stack diagrams show the value of each variable, but they also show the function each variable belongs to. So here we can see on the left we have the function names, and on the right we have a list of variables which belongs to that particular functions. So in the module we have, so by module I mean the main program. So the main program has line 1, line 2 variable, and cat twice has another variable which is part 1 part 2. So these are local variables as I specified earlier, which are known as parameters. And then we have cat. Further we have a function called print twice. So print twice has only Bruce, which is the local parameter. What else we have here is just a note saying that when the Python displays error, then the sequence of the function starts from the outermost to the innermost. So here the sequence is also same when the error is displayed on the screen. Mm, Next I have fruitful functions and void functions. So functions which return a result are called fruitful functions, and the functions which don't return a result are called as void functions. So that's what basically it means. Um, yeah. Functions with return result are called fruitful functions. Example math.sign, math.cos. Void functions are the one which return none or nothing. Example print. A user can define both void and fruitful functions. Yes, so this is there. Next. So here we have is I think mm, this slide might be repeated, but let's see it later. For now, we'll concentrate on why functions. So most of the time while writing Python program, we will repeat the code. So this usually happens that you're trying to connect to a database and you want to execute some query. So you don't want to open a new connection every time you execute a query. You just want to use the same connection for executing multiple queries. So in that case, you can use functions. In order to avoid repetition and make the program structured, you can use functions. So this point is there. Then functions alter the execution of program flow. So we did go over this point earlier using our examples of function. Then next point we have is creating new functions give you an opportunity to name a group of statements which make your program easier to read and debug. Yep. So we have also gone over this thing. I think this slide should be placed up more ahead, like at the top, instead of at number 13. So what I'll do is I'll just, not now, but after the video, I'll update the positioning of this slide. Next, we have importing with from. So earlier we saw that for importing the math module, we just wrote import math. But what about from? So at times what we don't want to import all the functions in a module. So what we will do is use maybe from math import star or import the name of the particular function like ABS. So here I've given a very small example. So from sklearn.preprocessing.text, I just want to import count vectorizer. So this is a small example. So from this module, I only want one single function. So using from, we can implement that specific idea. So let's go over the points here. In a Python program, imports can be made at any line. Okay. There are two types of imports, A using import and B using from. So we went over this one and we are now going over the second point. Generally, we import modules using the import keyword. Yes, but if you want to import some specific modules, we can use the from import construct. So this is basically the construct. Here we will have uh, module. So this should be better to understand. Function name. Yep. So just a quick note here. The advantage of importing everything from the math module is that your code can be more concise. The disadvantage is that there might be conflicts between names defined in different modules or between a name from a module and one of your variables. So what the second sentence says is that if you import POW from math and you also have a custom function POW defined, so if you don't have proper naming convention to use the function, there might be certain errors or conflict while using the function name. So be careful of that. Moving further, we have return values. So what this first point says here is in Python functions, you can return values using return keyword. Yes. But you can also return multiple values separated with comma. So yes, this is just a small example here. Here we have def, calc values, bag and product. And here we are returning multiple values which are separated by a comma. So this would return a tuple. Basically, when we specify the values separated by comma, hmm, yes, so that is what is specified in the fourth point here, which says that when there are multiple values in the return statement, the return object will be a tuple which you need to unpack. Total discount price is equals to calc values, bag, and product. You can have multiple return statements in a function. Okay, this is also true. Moving further, we have incremental development. So I'll just go over the key aspects because this is what is emphasized more here in the points before the key aspects. So first aspect is start with a working program and make small incremental changes. At any point, if there is an error, you should have a good idea where it is. Then second aspect we have is use temporary variables to hold intermediate values so you can display and check them. Third point we have here is once the program is working, you might want to remove some of the scaffolding or consolidate multiple statements into compound expressions, but only if it does not make the program difficult to read. So what these aspects are trying to emphasize is that by following them, the development of a complex program would be quite easy and you would make less mistakes or less bugs. So that is the major, I would say, idea behind incremental development. Moving further, we have, hmm, okay, what we had earlier was the same. This is composition from the point of view of a function. Composition for function. Okay, so this composition is different from the earlier one which we saw. So here the composition refers to the presence of a second function call inside the first function call. So here we call cat twice and cat twice again internally call print twice. So that is composition. Basically, that is what specifies in this point and in this text here. Moving further, we have Boolean functions. So what are Boolean functions? Is they are basically functions which return us true or false value. Boolean value. Okay, here we have one function which is alpha. So basically, what is alpha does is it checks whether the string contains only letters and no special symbols. So it will return true or false based on the evaluation of a function. So the output of the Boolean function would always be either true or false. Mm, This slide emphasizes the stack diagram for a recursion function. So here we have a module first. Module means a main program. In main program, we don't have any variables. Then we go to the factorial function. For factorial function, we want to find the factorial of 3. So that's why the parameter value is 3. Then we evaluate further the value of recurse. So the value of recurse would then be the value of factorial of 2. So we will call factorial of 2 here and then we will calculate the factorial of 1 until it reaches 0. So then we stop our recursion and return the value back. So at last when we get n is equals to 0 we return 1. Then in same manner we get the factorial of 3. Next we have a leap of faith. What do we mean by leap of faith? Is basically that assuming a function call works correctly and then moving ahead in the flow of execution. So we are practicing this leap of faith. Second point is we are practicing this leap of faith concept through the use of functions like math.pow or math.sin. So basically we are assuming when we are using these functions, which is math.pow and math.sin, we are basically assuming that when we will pass a value to them, it will return the result back. So this is a concept which should be kept in mind when trying to write recursive programs, because using this will make writing quite easy. Recursion function quite easy. So what that text at the bottom says is same is true of recursive programs. When you get to a recursive call, instead of following the flow of execution, you should assume that the recursive call works. Mm, yes, so yeah, you should assume that the recursive call will work in your function. So that will help you to write the logic for the program. Next and the last slide we have is checking types. How are we checking the types of the function parameter? And by checking the type, we can alter the flow of execution. So first point we have is checking the type of the argument or the type of variable is known as checking types. Yes, we need to check the type because in many cases we want to stop our processing. So this is basically just a reason why do we need to check the type. So we might want to stop our processing when a certain element or value is reached. Certain type of type of element or value is reached, or we want to exit the function call when a proper input is not provided. So for this cases, we have two functions, which is instance and type function. So here we have a factorial program, and we do not want to calculate, we want to calculate factorial only for integer numbers and not for floating point numbers. So here we are using the is instance program, and then n is the parameter for which we want to conduct the check, and it should match to integer data type. If it doesn't match, so then we will print an error message saying that the factorial is only defined for integer numbers, and then we will exit the function call by returning none. If it is an instance of integer class, we will calculate the factorial and return the factorial as is. So what do we have here is yeah, just a quick note here. What is the basic difference between is instance and type function? So is instance is a Boolean function in which we check the data type of given parameter, and we have to specify the data type which we want to check that whether the parameter belongs to the specified data type or not. Type function basically is used for not checking, but basically to know the data type of the specified parameter. So is instance is Boolean and type is not Boolean, but both of them are fruitful functions and not void functions. Yes, so we are at the end of these slides, and feel free to specify any suggestions in the comments. Please press the like button if you like the video or dislike if you don't. And once again, thank you so much for hearing me out, and see you then. Thank you.